to the organic chemistry class. Today we are going to see about the organic polymers. Poly means many. The meaning of the poly is many. Mer means a molecule. So the together the meaning is so many molecules joining together and becoming into a big molecule. Definitely the joining molecules will be when considered to the final molecule, they are smaller molecules. So you can define a joining of a smaller molecules, many smaller molecules into a long giant molecule formation is known as polymerization. Such a molecule formed is also polymer. Polymers can be classified, classification of the polymer. They can be based on different methods. They can be classified into the 4 types. First type is based on occurrence, where they are available, where we can availability or occurrence. They can be classified into 2 types: natural polymers and synthetic. Synthetic means man-made the polymers. Natural means in the nature itself we are able to get. Especially all the organic molecules are derived from the either plants or the animals. So therefore they also natural polymers also called biopolymers also you can call. So either in the plants and the animals you get this one is called biopolymers, like the carbohydrates. Carbohydrates in the form of long chain, that is cellulose, starch and silk, wool, these are all natural polymers. And natural rubber, synthetic means the polyvinyl chloride, PVC, a plastic and nylon, bakelite and so on. These are all man-made polymers. But the polymers which we are getting from the plants and animals are called natural polymers, are especially under the carbohydrates we have cellulose, starch, silk, wool, they are proteinous material, and the natural rubber, proteins, DNA, RNA, also natural polymers. Now this is one type of the classification. Another type of classification based on the method of formation. How these polymers are formed, based on that also we can classify the polymers into the 2 types. First one is addition polymers. Addition is the method of linking. An example, if ethylene is joined with ethylene. So the main reaction what is happening is the pi bond becomes into minus and the minus attacks on this. In fact, this pi electrons will come here and the pi electrons will make a bond. A long chain is formed. Finally, what you will get is a CH2 and a CH2 with a long chain. N number of ethylene molecules are joined. This is called a polyethylene or commonly called polythene. So polythene is formed by the adding the 2 molecules, that's all. This type of examples will be the PVC is one of the Teflon, okay, Buna rubber and so on, several polymers based on that the addition method. The other method is the condensation method. What is this condensation means? A carboxylic acid, for example, if I have a compound like a carboxylic acid is there and amino is there, this is a glycine. This glycine, if it reacts with another glycine like CH2, NH2. The OH of the COOH and H of this one is removed as a water molecule. However, here we have a continuation. So, what comes net is a CONH bond is coming and it is linked. So, the COOH again reacts with another the hydrogen of the amino group and so on, it continues. But in every stage whenever the reaction taking place, one H2O molecule, probably many times, sometimes alcohol, ethanol molecule or ammonia molecule, sulfur dioxide molecule, some small molecule is removed, especially if the water is removed, formation of water we call condensation. Therefore, the condensation polymers will have the removal of the water. So, therefore, they are called condensation. In fact, you can also have a third type of the in the polymers formation itself, that is copolymerization. Copolymerization. In the copolymerization, so X molecule is polymerized with Y. So, you will get a X instead of X coming, sometimes the Y also comes in between. So, the Y is inserting in between the X polymer, such a polymerization is called copolymerization. So, we do have some advantages of this copolymerization, is the mixed qualities not only, but we will have a certain times special qualities of the polymer also we are able to get. So, now let us go for the another type of the classification, third type of the classification, which is based on the structure of the polymer, based on the structure of the polymer. So, polymers can be line shape polymers are called linear polymers, and that means there will be a long chains will be there. However, in between van der Waals forces will be there, but the other side type will be the cross-linked or 3D type of polymers. That means a polymer and a polymer will be linked to the another polymer and make a net type of the formation you find, that is called cross-linked. It is in fact vulcanized rubber. Vulcanized rubber will be the example for this category, and bakelite. Bakelite is also a polymer of this category. Linear polymers will be the polyvinyl chloride, nylon, and several the molecules like polythene and so on. So many molecules which will have a line shape will be the linear polymers. If the lines are in between, joints are coming, in the vulcanization some sulfur atoms will be coming and making the attachments between the two links, that is called vulcanization process in fact. In the fourth type, based on the property, the fourth type of classification is based on property oriented. The polymers, most of the linear polymers will be there will be four types of this type. The polymers can be elastomers. Elastomers means the natural rubber. Rubber will have a elastic property, isn't it? Then we have a fibers. Fibers, nylon will be the one of the example. Then thermoplastic. The plastic, one of the advantage of this one is if it breaks, if you heat it, it will become again joined and you can go for the second time molding, that is recyclization of the recyclization. Example, the plastic, all plastic materials like PVC, polythene and so on. The other type is thermosetting. Linear polymers generally will have a thermoplastic, and the cross-linked or 3D type of polymers will have a thermosetting qualities. When once it is becomes a solidify, when you are polymerizing a solid polymer, when it is resulted, when you heat it, it won't easily melts up. but if you strong heat it, it will burn, catch fire, but there easily it will not melt. So, therefore, recyclization benefit will not be there, but our thermosetting polymers are used in the electric switches preparation or the ironing handles or pressure cooker handles and so on, because they can withstand for the high temperature. So, this is bakelite is one of the example. Resins and formaldehyde resins, most of the formaldehyde resins. Phenol formaldehyde and the other formaldehyde, melamine formaldehyde, other formaldehyde resins act as a thermosetting polymer. So, therefore, the mainly thermoplastic and thermosetting, however, based on the elastic nature and the thread making nature, we too have two more varieties, totally 4 varieties of the polymers are, that is based on the property we are having. This is about the classification of the polymers. Now, let us go something about the natural rubber. Natural rubber. Natural rubber is a polymer of CH2 double bond C CH3 CH double bond CH2. This is known as a 2-methyl 1,3-butadiene. It is commonly known as isoprene. The isoprene on polymerization, you are getting this rubber. In fact, this natural rubber we are getting from the plants, a plant called Hevea brasiliensis, commonly known as rubber plant. When you cut it, it oozes out the milk. The milk is added with salts and heated to coagulate. The water material separates and the organic material separates, in which we find about 90% of the hydrocarbon material. This hydrocarbon material was studied and finally resolved that this is the monomer of that the natural rubber. That means, in the plant we get this isoprene synthesis, and the synthetic this isoprene is preparing into the natural rubber. Okay. This isoprene, when it is polymerized, what happens? The double bond moves here, this double bond makes a new bond, and what will be the structure of the rubber means a CH2C CH3, a double bond will be in the center of the second and third carbon, and this will be the end times. A long chain will be there. This will be repeating unit will be there. A long chain of this polymer is known as natural rubber. You find here there is still one double bond is there. So, therefore, rubber is going to have certain reactions of alkenes. When bromine is added, bromination takes place. When you do ozonolysis, let us say treatment with ozone followed by the hydrolysis water in presence of the zinc, if you do it, it will cut here. Can you tell me what are the pieces you will get? Means in fact, you won't get 3 carbon 2 carbon piece, because there is another piece which is attached is also you should consider. So, this is the actually structure of the, isn't it? So, where you are cutting here and here. So, this 2 carbon plus 3 carbon will be the unit. So, CH double bond O and CH2 and CH2, C double bond O, CH3. This will be the product in the ozonolysis or the reductive ozonolysis of the natural rubber. This long chain is called a natural rubber. So, this rubber on ozonolysis, what comes 1, 2, 3, 4, 5 carbons. This is a pent compound containing a at 4th carbon keto is there. Therefore, you call it as a 4-keto pentanol. This is also called a levulaldehyde or levoaldehyde. Okay. So, this compound, when it is formed, also you can calculate that determine the structure of the rubber and where it is formed, what will be the monomer and all that. It's a fantastic study. So, thoroughly it was studied, and the natural rubber will contain this a long chain. It is a linear polymer, strictly speaking, and here and there some double bonds will be there, isn't it? So, this natural rubber will have a too much elastic gummy nature will be there. So, such a type of the polymers will have a linear structure, here and there double bonds with a methyl groups will be there, isn't it? A methyl group will be there like this. Now, this the that gummy type of the rubber, when you add some sulfur around 5 to 10%, you can add this sulfur. When sulfur is added, in between the double bonds and double bonds, there comes some the double bonds will open up and some linkages will be formed. So, this linkages involving the 2 sulfurs or this bit depending upon the length, 2 or 3 sulfurs will be added and this double bonds will be disappeared. These chains are called what? Sulfur chains. This process is called, technically called vulcanization. Vulcanization. What is vulcanization? Addition of some sulfur, around 5 to 10% of the sulfur to that gummy rubber, so that the fine rubber will be coming out. This rubber we call it is a natural rubber. Strictly speaking, this is not natural. It is partly we have done some reaction, that is addition of the sulfur. So, therefore, it is not totally natural, partly synthetic. Because of the addition of sulfur, we got this rubber. This rubber will have still some more double bonds will be there here and there. At every double bond, there will be a cis structure will be there. So, cis structure containing compound is having this the rubber nature or elastic property will be there. So, the rubber is a elastomer. Just now we have classified, it will have elastic property, means when you pull it, it stretches, leave it, it comes back to the original place. So, that type of elastic property because of the cis structure. At every cis structure, the compound will have something like a C shape, that is a cup shape. When you stretch without breaking, the cup can be slightly expanded. There will be millions of cups, therefore, it allows to stretch a certain centimeters length also, in fact, depending upon the type of the rubber and all that. So, based on this the natural rubber, we have identified why should we take that methyl containing 1,3-butadiene. So, therefore, based on this, that is a sort of imitation, in fact, the natural rubber, after studying the total study on the natural rubber, we have also gone for some synthetic rubber is also prepared. Synthetic rubber also we have prepared. So, instead of a methyl group, we have taken a chlorine containing the isoprene. Okay, this is not, if a methyl is there, it is isoprene. This chlorine containing the isoprene is called chloroprene. The chloroprene on polymerization. The polymerization, how you polymerize means just mixing will not get, you have to add the certain the polymerizing agents like acids or bases or radicals. In presence of a high temperature and pressure, the molecules will join up and you will get a molecule like this, SCH2 and SCH2, a continuation, a long chain will be, n number of molecules will be formed, that is called a polymer, right. So, if a chlorine is there, chloroprene, the polymer formed is called neoprene. So, question is also asked, where from neoprene is prepared. This is called polymer. This is a single molecule that makes polymer, is called monomer. So, therefore, question may be asked, what is the monomer for the neoprene, or what polymer comes polymerization of the chloroprene. Chloroprene gives the neoprene. It is also studied that only butadiene on polymerization also studied to give the a polymer called Buna rubber. Buna rubber. The rubber structure will be the CH2, CH double bond CH, CH2, this one. Okay. It is also studied that if you just give the heat and temperature, the cis structure, if it is formed well, it shows the elastic property. If the instead of cis, if a trans comes, what happens? Trans has no elastic property. Trans has no elastic property. Therefore, in the polymerization, we have encountered a big problem that sometimes you are getting a cis structured compound which is having elastic property. Sometimes a trans double bond level trans structure, if it is formed, you are no more, it is useful. Therefore, a scientist called Ziegler and Natta. Ziegler and Natta, they won a Nobel Prize for their work on these polymers. This Ziegler and Natta identified titanium tetrachloride plus aluminum trialkyls. the combination of these two mixture, this is a solid actually, heterogeneous catalysis they have used, and this catalyst using they have prepared, they control the stereochemistry of the polymerization and able to prepare, if you want cis only, trans only, the type of polymerization they are able to control. The catalyst is also known as Ziegler-Natta catalyst. Okay. What is the catalyst? It is a mixture of titanium tetrachloride and trialkyl aluminum. The combination is a solid. A solid catalyst is used in the polymerization by the Ziegler-Natta. So, the catalyst is called Ziegler-Natta catalyst. Polymers have one problem in the expressing their molecular weight, molecular weights of a polymer. If acetone is taken, a liter of acetone if you take, from wherever the part you take the acetone molecule, it will have a rigid structure, that CH3, C double bond O, CH3. Its molecular formula will be C3H6O. So, combination of this all molecular, the atomic weights, you will get the molecular weight of the acetone. So, a liter of acetone is given, calculate the molecular weight of the compound, means it is very simple. All the molecules will have identical structure, identical molecular formula, therefore, identical molecular weight. In the polymers, it is not that. A liter of polymer if it is given, from the top portion if you take a molecule, that will be in the sometimes 100 molecules, sometimes 1000 molecules, sometimes a lakh molecules, sometimes a million molecules may be joined. Therefore, no two polymer molecules will be identical. When an unidentical molecule mixture is there, so how can you express molecular weight of the polymer? So, therefore, it is very difficult, it is logically it is not possible to express the molecular weight. However, because of the mixture it is, but we have a method. The molecular weight can be expressed, the polymer molecular weight will be expressed by the weight, molecular weight, weight average. Weight average molecular weight, and another one is a number average molecular weight. There are two methods of weight is there. That is if you take for example in a given polymer, so how many molecules containing, let us say 1000 AMU units weight, that many numbers divided by that many weights, all the weights of the polymers will be added, each weight containing how many molecules, total of that molecule divided by, you will get the average. That is given by the molecular weight W. Okay. So, this is given by, that is shows all so many molecules 1000 and 1003, 1004, 1005 like that, divided by their number of molecules of that weight, average molecular weight you are getting. This is given by the molecular weight N. Okay. Both sometimes will give same value depending upon the difference in the number. If the difference is less, the MW and MN will be almost will be same. So, there is one poly dispersion index, dispersibility or dispersity index. This is called PDI. The PDI is given by the it is a ratio between the molecular weight by weight average molecular weight divided by the number average molecular weight. It is a ratio. The ratio many times will be 1, or sometimes maybe slightly more than 1 or slightly less than 1. If it is 1, we can conclude that the difference between the polymers weight will be very less. Sometimes if the molecular weight is more, that is if the number weight molecular weight is that is sometimes that molecular weight comes as 80,000 let us say, and number molecular weight you are getting 40,000, then if you remove it 8 by 4, that comes to a 2. So, the value will be more than 1, isn't it? So, whenever more than 1 you are getting this PDI, it shows the difference between the subsequent molecules will be more. That means variation in the polymerization is there, that point you can derive. This is called PDI value. Then we can go for the another aspect, biomolecules, biopolymers. In the biopolymers, we have from age old several molecules were identified as a biomolecule, especially in the carbohydrates. Carbohydrates, we have the starch and the cellulose, and in the blood we have a glucose polymer called glycogen. These are all basically polyglucoses, they are all polyglucose. How they are attached? Alpha linkage, beta linkage differs in the starch and cellulose, they are polyglucose. That is why when this polyglucose, when you hydrolyze it with H3O plus, what comes? Okay, hydrolysis, when you do it, n number of glucose molecules, D-glucose molecules will be resulting. That shows it is a big molecule formed out of the glucose. Carbohydrates, we have a huge number of biopolymers. In the proteins, proteins also long chain, the protein, so many molecules join up. If a two proteins is made up of with the amino acids, if two amino acids are joined, one amino acid is having a COOH and NH2. Amino acid is nothing but built up with the having the two functional groups, a COOH and a amino group. Similarly, another amino acid is containing a amino group and a COOH. Right. Now, this OH and the hydrogen, if it is removed, there comes a bond called CONH. So, this bond is called peptide bond. Peptide bond. If two amino acids are joined, you get a peptide called a dipeptide. A dipeptide will contain one peptide bond. However, but two amino acids if you join, you will get dipeptide. If one more amino acid is joined plus one more amino acid, then you will get tripeptide, and so on. You will get a polypeptide. Polypeptide. The polypeptides will resume certain structures, like the sequence is called primary structure, and it will go on coil up through the hydrogen bonding and also supporting of the other the positive charges, and the peptide in between the side by side also there may be some CONH links are formed, ionic attractions, and all that will give the tertiary structure, and then finally a quaternary structure. That type of the a big polypeptide acts as a sometimes an enzyme. Some of the hormones, insulin hormone, these are all having a specific structure will be there, a three-dimensional big structure will be there, and there the enzymatic actions are because of their specific three-dimensional structure, that is especially the quaternary structure of that enzyme is responsible to show that enzymatic property. These are all called the biopolymers. In the carbohydrates we have, in the proteins we have nucleic acids. Nucleic acid. They are also a big polymers like RNA and DNA are the two varieties of this one is there. A sugar unit will be there. A sugar unit will be there. It is attached with a phosphate, and the sugar will have a one organic base is attached, and this is a repetitive unit. Now, a sugar phosphate, sugar is attached with base. Again a sugar comes now, a sugar and a base plus a phosphate. This is at n times. So, it is going on developing a long chain. And what type of sugar is used? If it is a ribose is used, we call it is a RNA. If it is a deoxyribose is used, it is called a DNA. However, in DNA, the bases also we have two different types, pyrimidines and purines. In the pyrimidines, if in RNA it is uracil will be there. In DNA it is thymine will be there. Like that, there are some changes are there, not only the sugar unit, but the base also will be different, and these are both are the carrying on the genetic code, and they are bifurcating, that is replication, and that is given to the another cell, a new RNA will be created, and so on in the protein synthesis, and all that they are having a important role. So, the nucleic acid is also one of the biological polymers. We have some commercial polymers, important polymers, let us see. Polyvinyl chloride. Polyvinyl chloride is ethylene, as we have seen already. When ethylene is polymerized, you will get a polyethylene. What will be the structure of polyethylene? So, CH2, a CH2 will be N number. This is a ethylene polymerization mechanism. It can be a cationic polymerization, or it can be an anionic polymerization, or it can be a free radical type of the polymerization, like a dot. When it is used, it is a free radical polymerization. What is PVC means? Ethylene containing one chlorine here. This is called a chloroethene, or this group radical and function is called a vinyl chloride. This vinyl chloride, when you polymerize it, polymerization, that is condition, induce some acid, and high pressure and temperature if you apply. Then a polymer is formed, CH, a single bond CH, Cl, N number. This is called polyvinyl chloride. It is a beautiful plastic. You know the plastic advantage, it is water insoluble, and it has got the soft surface, it is flexible, it is unbreakable type. Number of times we are able to produce a transparent plastic also, see-through type of the plastics, which are having a water repellent, anti-corrosive, anti-chemical reactive. There is no double bond, so therefore it will not easily undergo oxidation or the rust formation. All such properties will be free. That will be a very much lighter also, in the density of the polymer will be very less, the lighter, and it floats on the water. So many qualities makes the preparation of the water toys and the instruments which used in the daily, the household articles, and so on. So, we have a polymer with a ethylene with a small change here in cyanide. This is called what? Acrylonitrile. When this acrylonitrile is treated, polymerization, you will get a polyacrylic products. And the structure will be similar to the vinyl chloride, a CH2CH, only thing is a cyanide will be there. This is called polyacrylic product. An ethylene holding a benzene ring is called styrene, is known as styrene. R-E-N-E, styrene. The styrene on polymerization, you will get a polystyrene, very popular substance. An aromatic ring is also there in this structure. So, water insolubility increases, stability extraordinary increases. So, this is called polystyrene. This is a polyacrylonitrile, the other one is polystyrene. So, in this synthetic rubbers, plastics, we too can have some copolymerized plastics. Plastics you can prepare. So, a butadiene when polymerized, I said Buna rubber coming, isn't it? Then butadiene is mixed with the styrene. Butadiene is mixed with the styrene. So, both they are different monomers are there, two different monomers are there. So, the question cannot come, what is the monomer of the so and so polymer, means there are two different polymer, two monomers are there. So, one is 1,3-butadiene, 1,3-butadiene. The other one is styrene. Both undergoes copolymerization. While copolymerizing, we have some problems here. So, sometimes 100 molecules of styrene at a time, and then 100 molecules of 1,3-butadiene also may come. That is called bulk type of the copolymerization. But depending upon the nature of the compatibility of the two molecules, sometimes exactly one molecule, one this, one that, the beautiful copolymerization takes place depending upon the compatibility of the molecules. You will get a Buna S. The capital S stands for the styrene here. Buna is a polybutadiene rubber, isn't it? Buna is a butadiene Buna rubber plus Buna S. Similar the way, if a butadiene is mixed with the acrylonitrile, CN, triple bond N. So, if this is polymerized, you are getting a Buna N. Capital N stands for the nitrile group is there, therefore, it is called N. So, therefore, one butadiene, okay, this is the butadiene part, and then you have a acrylonitrile cyanide, again a butadiene followed by the acrylonitrile, butadiene followed by acrylonitrile. This type of the copolymerization is also possible to prepare this the different types of the plastic materials. We have some polymers which are nature acceptable type of the polymers which are called polyamides, in fact, polyamides and polyesters. Polyamides and polyesters are more accommodative towards the nature. That's now we have seen a chlorinated products, cyanide containing products, they are poisonous. In fact, the toys made up of with these polymers should not be given to the children who choose that choice, the polymers, because they are not good for the health. But polyamides and polyesters are more eco-friendly type of the polymers, because they have a functional group CONH, which is there in our protein. The proteinous material, our body, especially the skin, the muscles, the hair, nail, all these are nothing but the polyamides only, proteinous material. Now, this polymer is also containing the same function, CONH, it is more accommodative. Similarly, an ester. Ester is also containing a carboxylic acid and alcohol joining you will get here, acid and amine joining, this is an acid and alcohol joining you get. A carboxylic acid and a alcohol, when polymerized, you will get the HOH removal and you will get RCOOH, which is also there in the proteins, in the fats. In the fats are triglycerides, simple fats contains triglycerides, which contain ester functional groups. Therefore, this is also more or less accommodatable, and also they are biodegradable. Both these two types of polymers are biodegradable. What is biodegradable? When this polymer is thrown away, and that will decompose slowly with the action of sun and water and some biological species, bacteria, virus and so on, they attack, they break this hydrolysis and they make smaller molecule, and it will come into the chain of that carbon chain, it will come, and so therefore there is no pollution. Whereas the plastic materials which are broken bucket pieces or broken these plastic bags, they are not degradable even for the decades and decades, centuries also they will be stored like that. Therefore, the carbon material is cornerized, or the cycle is not completed. So, accumulation or the carbon cycle breaking is a lot of biological imbalance comes, and that is, however, it is also giving a poisonous drainage problems and so on. But what are these polyamides? Let us say one of the beautiful polymer is nylon. How this nylon is prepared? Nylon can be prepared synthetically from oxidizing the phenol. You can prepare a cyclohexanone. The cyclohexanone can be converted into its oxime. The oxime, a reaction with a sulfuric acid, it undergoes a rearrangement to give a 7-membered ring which is containing a NH and C double bond O. Okay. This on hydrolysis you will get a amino group CH2, 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 CH2. How many CH2s? 5 CH2s containing a carboxylic acid generated. This is called a total 6 carbons are there. 6 carbon oic acid is called commonly caproic acid. Caproic acid. So people said this is a caprolactam. Caprolactam is a internal amide. Lactam. The caprolactam on hydrolysis with water acidified, you will get this capro on the acid, 6 amino caproic acid. Now this polymerize it. What you will get is this NH2 joins with another carboxylic acid OH, and here we have a NH2, right? A long chain ending with COOH, again a long chain NH2. Now we have this OH and H will be removed, OH and H will be removed. Like that, wherever they join, one H2O will be dropped, a long chain CONH and a long chain, that is 5 CH2s will be there, again a CONH. It is nothing but a polyamide containing 6 carbons. So derived from the 6 carbon, therefore it is called a nylon 6. The 6 stands for the 6 carbon, the acid containing a amino at one end. 6 amino, the carboxylic acid is polymerizing, you are getting a nylon 6. So the nylon is so accommodative. When you have an operation, the nylon threads are used for the operating. After operation, you can leave the threads dissolve into the body, because this is also made up of with a amide. So amide is so accommodative. So therefore they are not that dangerous for the universal pollution. So even the nylon, when it is exposed to the sunlight light, also slowly it is decomposing and converting into the bacteria can be affecting on this and degrades into a smaller molecules and utilizes the energy released in the hydrolysis. So these are called biodegradable type of the polymers. Similarly, there is another polymer which is from the acid and the alcohol. Okay, there is one, a carboxylic acid called this is a 2 COH side by side. One COH is called benzoic acid, side by one more COH is called phthalic acid, but opposite is called terephthalic acid. Terephthalic acid. Terephthalic acid. This when you treat it with ethylene glycol. Ethylene glycol. Ethylene is a double bond one, but a glycol, when you oxidize with permanganate in alkaline medium, you get a glycol. The glycol and acid, when it is treated, HOH is dropped, you will get a COO. These are called an ester linkage, isn't it? So an ester linkage is linked, they are called the terylene. Terylene type of the material is formed in a terylene. Recently, some type of the polymers, commercially it is known as a polyhydroxy valerate. Polyhydroxy butyrate and valerate, PHBV. This is a biodegradable type of the polymer. Biodegradable. What is its structure? It is a butyrate. Butyric acid means a containing a OH. This is if it is polymerized, it is a hydroxybutyric acid. Hydroxybutyric acid. Similarly, hydroxy valeric acid. Valeric acid means what? 5 carbon carboxylic acid is called valeric acid. Either beta or gamma or delta, if OH is there, the hydroxy valeric acid, just now here you see, it is a diol and diacid. Instead, one compound can have a ester and alcohol. Now, another alcohol, if it is polymerized, what comes here? poly, okay, this is the hydroxyvaleric acid. So, the ester is formed here, it is called valerate, it is called valerate. Valerate will have a, then now this O will come here, okay, a long chain will be formed here. Okay, this ester function is there. So, these type of the polymers are called polyhydroxy butyrate. This is a 4 carbon one is a butyrate, and also it is copolymerized, in fact copolymerized with the valerate. So, butyrate and valerate polymers of esters, polyesters, it is called polyesters. These polyesters are perfectly the biodegradable. So, therefore, instead of going for the plastic type of material, the polyesters or polyamides, if you can create such a polymers in the industrially, if you use the outlet, that is thrown waste materials will be again undergoes into the cycle of the carbon cycle will be completed. So, the esters and the amides are biodegradable type of the polymers. So, this and they covers the most of the polymers topic. Let us have some the previous questions. The topic is in fact introduced recently, therefore, there was no much questions in the old papers. Recent question papers we have. The monomer of neoprene. Neoprene is the original one is a natural rubber, slightly modified, that is instead of 2-methyl we have a 2-chloro-1,3-butadiene. If you polymerize it, it's a neoprene. I said already, a chloroprene is nothing but a chlorine containing isoprene. This on polymerization you will get the neoprene. So, what is the monomer? 2-chloro-1,3-butadiene. Answer 2 is the right answer. The monomer of neoprene is a 2-chloro-1,3-butadiene. In the neoprene also you have a structure like this, a double bond will be there and the chlorine is there. At this double bond it will have a cis configuration. That cis configuration is going to generate the elastic property. It is going to get the elastic property. Therefore, this neoprene is used in the rubber bands preparation, much elastic property than so called natural rubber. Next. Which one of the following is not a biopolymer? Biopolymers are also called as natural polymers. Now, synthetic polymers you have to identify. Cellulose is a biopolymer. Okay. Nylon 6 is a man-made one. I said it is prepared by the hydroxy amino carboxylic acid, nylon 6. Insulin is the polymer which is made up of with the proteins. DNA is a nucleic acid which is a polymer. Okay. It is a base and phosphate and the base and sugar, and both 3 units are replicated. A long chain is called DNA. Stands for the nucleic acid. It is a deoxyribonucleic acid. Ribose will be 2-deoxy will be there, DNA. So, the polymer is a nylon 6 is a synthetic polymer or not a biopolymer. Right. Next. If the number average molecular weight and average molecular weights of a polymer are 40,000 and 60,000 respectively. Okay. That is a weight, average molecular weight is given as a 60,000 and number average molecular weight is given as a 40,000. What he was asking is a polydispersity index. Polydispersity index he is asking. This is given by the weight average molecular weight divided by the number average molecular weight. This equation is giving the PDI. It is nothing but a ratio with reference to these two. So, you have now the 60,000 divided by 40,000. So, 4 1s 4.5. So, therefore, it is 1.5. 1.5 is a greater than 1. Therefore, so therefore, answer go to the greater than 1 means answer is 1. Okay, right. This is called polydispersity index. if Mw is the weight, average molecular weight, and Mn is the number average, the bar will be there on the M. So, that shows it is an average molecular weight of the polymer. The that is poly dispersity index, PDI of the polymer is given by the, it is an average between the weight by N. Weight will be on the top, the N will be on the down, numerator by denominator, numerator will be the weight. So, this will be always many times it will be the higher values are coming. So, the higher value by the lower value will be the, you have to remember. So, this goes to the answer 2, weight by the number, Mw by Mn. Which of the following is a biodegradable polymer? Because nowadays the polymers which are degradable type, which are not degradable type, this talk is nowadays a very current topic. The pollution, the environmental pollution is because of the most of this polymers usage, and the polymers as it is stable, it works well, but when you throw it, it is stable, therefore it won't decompose. That is the problem we are getting, isn't it? Polythene is a polymer of ethylene, and polymerizing you will get a polythene, quite a stable structure. See where it is degradable, it is an alkane. Alkanes we know they are paraffins, highly stable molecules, isn't it? And the second one is bakelite. Bakelite is a formaldehyde and phenol together will give this bakelite. Phenol plus formaldehyde is going to give a reaction in the basic medium. The formaldehyde comes in between the two phenols, CH2 unit. That means one benzene hydrogen, phenol hydrogen, another phenol hydrogen undergoes a condensation. This type HO is removed. So, CH2 comes in between the benzene molecules. The reaction is not over, in fact. The other side, one more hydrogen will be consumed and you are getting another formaldehyde linked to this side. Here also you have a CH2 linked. And again it is not continue, that is not over. So, para hydrogen may also link with the another para compound. So, the link development may also takes place this side also. A phenol, reversely if I write in fact, if you consider this is a line, this is a line, the lines are joined with the CH2 units. So, what type of polymer it is? It is a cross-linked polymer, two lines when it is joined here and there, then what happens? It is a cross-linked or three-dimensional polymer. Three-dimensional polymer. This 3D type or cross-linked polymers are very, very stable. They will not undergo again this biodegradability will not be there. The bonds between the phenol and phenol is also through the hydrocarbon C bonding. There is no ester or the amide bonding. So, the bakelite is also very, very stable. So, unless you break into pieces mechanically, you have to break, but molecular level you cannot break. So, therefore, bakelite is also very problematic. This one, it is a thermo setting polymer. Once it becomes polymer, if you heat it, you won't get a liquid also. It will burns into air, but not becomes into the liquid. Whereas the third one you see PHBV. PHBV already we have taken, polyhydroxy butyrate. Polyhydroxy butyrate and valerate. Similarly, valerate. The valeric acid hydroxy, a compound containing a butyric acid means 4 carbon carboxylic acid containing a OH at either at beta, gamma or delta. A hydroxy butyrate undergoes a esterification. So, esters undergo this type of the biodegradability. The last one is a vinyl chloride. Vinyl chloride on polymerization you will get a polyvinyl chloride. So, this is also a non-biodegradable type of the polymer. N number of the molecules joining. So, ethylene, polythene and polyvinyl chloride, bakelite, they are all hydrocarbon type of the materials which will not undergo biodegradability, whereas only the PHBV is the member which is there in this 4 categories is known as a biodegradable type of the polymer. Some of the polymers, which one of the following is the molecular formula of the this is different amines chapter it is. So, leave it. There are only 5 questions are there in the as I said, the topic is a new topic which can be only introduced recently. So, therefore, very few latest year questions are there, but not in the last few years. In the polymers you can have a certain topics like there is another polymer I will introduce, nylon 66. This nylon 66 is also a biodegradable type of the polymer which is prepared by the acetylene on polymerization with a copper chloride and ammonium hydroxide, copper chloride, ammonium chloride. You will get a vinyl acetylene. This on treatment with partial reduction with hydrogen with Lindlar's catalyst, you will get butadiene. This is the method of preparation of the butadiene in fact, right. So, this butadiene you can use it for the Buna rubber and so on, but the acetylene can be acetylene has so many lot of sources for the different polymers preparation. Use formaldehyde in presence of the copper catalyst, you will get a hydroxymethylation. This on reduction with the hydrogen nickel, you are going to get a 4-membered like this. Okay. Here also this also you can prepare from the adding the HBr anti-Markovnikov rule dibromo type of the compounds, which on hydrolysis also you can prepare anti-Markovnikov rule, peroxide effect if you use bromines will goes to the terminal. This compound and adding the chlorination or iodination, let us say I2 and phosphorus iodination, followed by the cyanide, sodium cyanide or potassium cyanide, you will get the 4 carbon with the cyanides. 4 carbon with the cyanides. Now, this compound has 2 the different reactions. One is you go for the hydrolysis. In the hydrolysis, cyanide groups will become into the carboxylic acids. What acid you got now? This is a 6 carbon dioic acid. 6 carbon dioic acid is called adipic acid. Adipic acid. The other side you reduce it with hydrogen and the nickel. The cyanide will become into CH2. These 4 carbons, in addition to that 5th carbon with NH2 and 6th carbon with NH2. So, this is called a adipic with diamine, adipine diamine. This is known as adipine diamine. Adipine diamine. Now, these 2 compounds are together polymerized. It is a copolymerization in fact, but it is this is dicarboxylic acid, this is diamine. Now, one diacid will come, or let me write a CH2 with the 4 times with the CO. Okay, this is called a dicarboxylic acid. Now, a diamine starts NH with a CH2 6 times NH. Okay. Now, this unit is N number will be there. A dicarboxylic acid is known as adipic acid, a diamine which is a adipine diamine. This is called nylon 66. Nylon 66. So, a polymer wherein we have a function. What is the functional group? Amide functional group. So, therefore, it is again a polyamide. So, all these polyamides and polyesters are very good, wonderful biodegradable type of the polymers, because bacteria can attack, the molecules will become pieces and the cycle is maintained. Therefore, they are all biodegradable type of the polymers. So, I think this enough for the polymers. The next class we will have some biomolecules and the medicinal, the molecules which are there in the everyday life. So, such a topic we will take in the next class. Thank you.